Uh-oh, it's Harold Spud. Hi guys, it's ESP32 time again. This is part 2 of all my videos, 2 out of 2 at the moment, but we're going to do something a little bit more interesting with ESP32 today. This is the thing we're talking about. It's a little ESP32, it's a microcontroller, and so far it's been a little bit tricky to use because we've been using Arduino and the language that comes with it, which is like C++, which is okay, but tricky old language. So I thought, well, that's a bit hard. Let's do something different. And what we'll do is we'll use MicroPython with it, which makes it nicer for me because I'm a sort of Python person and I like doing Python stuff. But also we're going to use this little beastie here, or something like it, which is an MCP23017. And it's a port expander. It talks to the ESP32 on a serial data bus, the I2C data bus, and it allows you to talk to the pins on here, which has 16 pins, and you can use them just like GPIOs. So that'd be really nice. Let's have a quick look at the thing that we're going to be doing today. And this is the thing here. It's the ESP32 is here. The 23017, you see, it's this chip. This is not a module, it's a chip on here. And there's loads of LEDs in here. These connect to the ESP, to the MCP32, MCP23017. Oops, difficult day today. Boom. And all we're going to do is make the LEDs flash. Now we've done all that here, and this thing actually works. Otherwise I wouldn't do this video because it took me a while to figure it out. This little thing here is an SD card, and I wired it in, but I'm not using it yet because it takes a bit more work and I can't be bothered to do it just yet. So we'll just do it as it is. So let's just power up and see what happens. My battery supply for this is 4 18650 batteries, which is good. And on the end here, there's a little 5 volt buck down converter. It converts from the 4 times 3.7 volts down to 5 volts here. Do be careful when you use these that you configure the little adjustment trim pot there and set it to 5 volts. I failed to do that once and blew something up. Don't do that. So here we go. Let's just power up and see what happens. So what have I done? This is a really useful project. Not. All it is a thing that randomly flashes one of the lights that are there. Most of my LEDs are like green. One of them's white, one of them's blue, and I think one of them's yellow. But there you go. So it just randomly flashes them off. And this script starts automatically when the thing is powered up. And I'm powering it up through this red and blue wire. Yeah, it should be red and black really. If I take the power off, it's no big deal. So already we've found something that's better than Raspberry Pi, because we've just rudely interrupted it and cut the power, and next time you start it up again, it happily works again. You can't do that with a Raspberry Pi because they get upset very easily and they'll mess up their file system and you have to do FSCK to fix them. So ESP32 is a lot more rugged than Raspberry Pi. So there we go. There's our first thing here. Here's our ESP32. It's running MicroPython and it's talking along its serial bus on the purple and white cable there to the MCP23017, and it's setting them to 1 and 0. Do note that here I'm actually using 5 volts for the MCP23017 port expander, but the ESP itself runs on 3.3, although it's powered by 5 volt and it's got its own down converter inside. So we're powering here on the 5 volt line. The outside is, the orange is 3.3. This creates its own 3.3, and we're there. So let's have a look how we did it, shall we? Okay guys, let's have a look at the ESP32 and the MCP23017, and what we'll do is we'll have a look at what we have to do to make them talk together. So we've got the ESP32, and it's a nice little microcontroller, and it's got lots of little GPIOs on there. GPIO is kind of a Raspberry Pi term. In actual fact, we're going to use the term pin from now. So we've got lots of these on here, but in actual fact, a lot of them are used up, so we can't use these. So what we're going to do is we're going to get an MCP23017 port expander, which is a 28-pin device, and we're going to connect across to here. We're going to connect SDA and SCL, and we're going to connect the earth across here as well. So we've got ground across here as well. Ground, which is 0 volts. So I always have a 0 volts line that connects it across there. And also we want to connect to this here. We want plus 5 volts. It actually will run on 3.3, but I don't want to, because I want to drive the LEDs and be sure they can work. Now we've got to be very careful with this here. Into here we've got a maximum of 150 milliamps, so we need to be very careful. We don't want to drive more than 15 LEDs or on at 10 milliamps, because that's going to exceed the capability of this. And each particular pin on here, these are the pins, are I think 15 milliamps. I think they're 15 milliamps. I have to check that later on. 15 milliamps max each. So I'd be careful with this here. So these pins on here can be addressed, and the ESP32 can talk to them. But this thing here comprises a serial data bus. And all the commands go from one to the other. Go from the ESP32 to the MCP23017. Or this thing can generate an interrupt and tell this one to stop what it's doing and listen. So we can get inputs and outputs. And you can set these pins as input or output. And with these pins here, what I've done with mine is I've connected them to an LED. Isn't that a nice LED? And then through a serial resistor, which is about 470 ohms, and then down to earth. So we've connected it so that if it does a logic 1 as an output, then the LED will light up. And that's all I've done really. Now I set this up as it was, and it didn't work. And I thought, oh, it doesn't work. Why doesn't it work? And the reason is that these two pins here at both ends are open collector, which means that they need to have a pull-up resistor. So you need 4.7K, I'll say 4K7 and 4K7 there. That means 4,700 ohms, and that's pull-up to plus 3.3 volts. Don't pull it up to 5 volts, because this thing here is plus 3.3 volts. And this one's plus 5 volts, but it'll be happy with 3.3 as a 1. Because anything more than 2.4 volts in 5 volt logic is a 1. Anything less than 0.8 volts is a 0. But hey, you know this. Well, I do anyway. Right, okay. So there we go. We're going to connect them together, and we're going to make them all light up. So let's have a look at how we program the thing. This is an interesting thing itself. What I'm going to do is I'm just going to go get a command prompt up here, and we'll just share my command prompt. There it is. There, it's a nice little command prompt. Now, the first thing you'll do if you want to put MicroPython on your machine is to install the ESP tool. And if you've installed Python already, you'll have pip installed on the machine. So pip install ESP tool. Now my machine already has ESP tool installed on it, so it's already done, so there's no big deal there. Your machine, you might not, so you might have it install it and install it. In actual fact, it might be better to do pip 3, because we're using Python 3. So pip3 install ESP2. Hey, that's no big deal. It's been done already. So once we've done that, then we're going to flash the ESP32 into MicroPython and give it a MicroPython core. It's kind of an operating system, but not really. It's very cut down. Now, here is, let's just stop the share on that a minute, and we'll just share the visualizer again. Here we go. There's my visualizer. Here's my little ESP32. What we're going to do is get a cable, which is a micro USB to full-size USB, plonk it in there, and plonk it into my PC, and then I can flash it. There we go. That's better. Right, okay guys, so we've got this little ESP thing. I've used the standalone ESP32. It's powered up, it's on its own. How it comes to me is via, it just comes as it is, but it's got the Arduino interface and the Arduino language core built onto it. It doesn't have MicroPython at all, so we need to change it. And this is how we're going to do it. Are you ready? Here we go. I'll just share all my screen because that's the sort of thing I do. Pardon my dog. I've written all the commands down here to help me because, like, I forget these things. But hey, you know, many people forget these things. It's just what happens in life. So where are we up to? MicroPython. Number one is command prompt. Then we do in pip3 install ESP tool. Go to MicroPython's site, and you need to get hold of the flash image you want for that. There's micropython.com, I think, and you just go there. It's brilliant. It's got everything. And then we want to do this thing here, which is ESP2 port COM3 erase flash, and that means you need to erase everything from the machine. Now, this is always a dodgy bit in any installation because as soon as you erase it, you think, oh, crikey, can I get it all back again? But hey, yes, you can. No big deal. So we'll do that here. We'll do ESP tool. Oh, by the way, before we do anything, COM3, really important. Find out from your device manager which is COM3. Now you need to look at where we go to network adapters, monitors, ports and COM. There it is there. And it will say Silicon Labs CP210X USB to UART bridge COM3. Make sure you're not trying to flash or format any of your other USB devices you've got on there. That's the one there. So we need to do ESP tool .py. It's actually a Python script that's doing this for us. -- port COM3, which is the port, then erase _ flash. This sounds a bit dangerous, but there you go. And then we'll just press enter. So it's say connecting. At this point, you have to press the little button on here. So I'm going to press the little button on the thing, and it'll then suddenly say it's connecting. And there you go. It actually is erasing the flash. So what it's doing now, it's wiping my ESP32. So it no longer has any firmware on it at all, nothing. It's kind of blank, really, which is a bit dodgy, really, because now I've got my little device here. It's not going to run MicroPython. It's not going to run Arduino. It won't run anything. But what we must do next is to install MicroPython. And that means we have to go to the place where I've installed the thing. I'm just going to pause the video for a minute. I'm just going to find the file. Pardon me 1 minute. There we go, found it, yay. And I put it in this folder here. Notice I've got two files in, oh, no, I can tell you what, let's just share screen again, beg your pardon. Oh, there you go. Right, let's continue then, shall we? So I found the file that I downloaded off MicroPython's site. In fact, I've got two here because I've got two chips here. I don't use the other one very much. ESP8266 is an older version. It's not as powerful, but it's a nice chip. And you can still use it. I might do that yet. ESP32 is the one we're using, and it says something or other ESP32.bin. This is a flash image from MicroPython, and this is what I want to flash onto my ESP32. So what we're going to do is we're going to do cd up to root directory, cd to the folder where it is, dir, what have I got there? And I've got 2 bin files. Notice that they're actually quite big. They're big files. ESP32 is especially big. How big is it? Big, big. Very big. It's 1.2 megs. Well, that's not how big, but it's big enough. All right, okay. Let's have a look and flash it on the machine. So we need to follow the commands that I've written down for myself, which I've probably done wrong, but there you go. So I've said get bin file from there, ESP2.py, -- chip ESP32, and ESP32 is what we're going to do. Otherwise, it'd do the other one. -- port com3. We're still on com3, and then we need to do the name of this file here. And I'm just going to go and grab hold of that file there. Just grab hold of that one. Control key, C, copy. And here I'm just going to paste it in place. There you go. .bin. So there we go. .bin. And what else do we need to do? We've missed some bits out, haven't we? com3. After com3, -- baud 460-800. That's speed. And then write _flash -z 0x1000. And that's it. Then we've still got to press the button on the actual little device here, where here he is here, to actually make it flash. Now, interestingly here, the -z 0x1000, it means start writing at memory address 1000. You can't start at the beginning, it'll all go wrong. And 0x, which we're going to use a lot later on, means hexadecimal. So let's have a go with it. What's going to go wrong here? There you go. So press that serial.connect, and then I'm going to press a little button here on the thing, and it's connecting, and it's flashing my ESP32 with MicroPython, which is brilliant. And that will have all of the Python modules and everything I want, time and random and everything, all the things I know and love. But it's not going to have the extra drivers for the MCP 23017, which is our next quest. And that's the bit that took me a few weeks to do, actually, to sort out exactly how to get it to talk to the MCP 23017. So there we go, hard resetting and leaving via whatever it is. That's fine, I can just unpower it now. It's all sorted. What does it say? Press boot button to upload, press the enable button, and there you go, that's it, done, sorted, it's booted. Then we can just unpower it, and there it is. This machine now has MicroPython installed on it. I can use MicroPython. Isn't that nice? I like that. Let's have a look. Let's just stop the share a minute here now. So the next stage is to talk to this with Python. Now, up to now in my limited career of many things, I've used idle as an IDE for Python. I've used a program called idle to do all my programming in Python, which is fine. Debugging's not much good, but it's a lovely little program. But there's a new one out called Thonny, which is better, I think. And it also talks to ESP32s, and it will do MicroPython. So the next thing to do is to install this program called Thonny, Thonny, and then what we'll do is we'll run that on the ESP32, and we can talk directly to the ESP32. Okay, see you in a minute. Hi guys, let's get going with the ESP32 with the programming with the IDE called Thonny. Now, what have we done first? We've taken our ESP32 and he is connected in on the USB cable. Now, are you thinking, how am I going to talk to him? You could use the Arduino IDE, but hey, I don't want to do that. What I'm going to do, I'll just start up Thonny and I will share the screen with you. Here we go. So this is Thonny. There you go. And at the moment, Thonny is saying, well, it's not doing very much at all. But notice down the bottom, I've got here a MicroPython command line here. Now, I've told Thonny already that it's got, where are we up to? Tools, Thonny system folder. I've told them to run processing on COM3 onto the ESP32. So in fact, what we can actually do is we can run commands on here, 3 plus 5. You know, I've taught maths in the past, 8, yay. So we've actually got the ESP32 to do some work for us. Now it's just like Python, where you have with idle, you have an editing window and command window. This is the command window down here. Now what we can do here, we can write some Python, so we can say x equals for input, enter a number, and of course we've missed all the bits out, but we always do that. We'll say y equals input a number, and then we'll say print, oh, I don't know, x times y. That seems reasonable to me. Now we could just run that if you want, and that will run it. Where do I want to run it? My computer or MicroPython device? Well, we know it's going to happen on my computer. Let's run a MicroPython device. Let's save it first of all. We're going to save it to main.py. Now on the MicroPython device, boot is the thing that always starts up when the machine runs, and main is the first program that will run after boot. So never mess with boot, but always mess with main. So we'll say, okay, do you want to overwrite? Yeah, okay, we'll overwrite it, saving. It says there, enter a number. So we'll enter 5. It says, oh, 5555, because we haven't really done arithmetic at all. We've just done appending. We've done 4 times 5, and the 5 is an ASCII character. So we could change our program here. We could say y equals integer of input, enter a number. This is a common mistake. Even I make this mistake. There you go. I will save it. Where do I want to save it? To the machine. That's okay. And we'll run it again. Enter a number. 6. Oh, put ourselves in the right window there. 6. And now we get 24. Brilliant. It runs. So we can run code on the ESP32 from our IDE, from our Python program, which is brilliant. So hey, let's just open a recent file. Now I thought, well, this is a lot easier than Arduino, but what we'll actually do is we'll write a little program here, and our little program is going to flash the lights on the ESP32. So we're importing machine, and that gives us one or two things. First of all, it gives us a thing called pin. Now if I say pin something, it's like a GPIO command. So down here, that's mcp.pin. I'm not going to do pin just yet on that. But I've also imported this thing here, and this is written by a chap on GitHub, which is brilliant, because it saved me all the trouble of doing it, which would take me ages if I could do it at all. Import time like normal, import random like normal. And my little program says down here, while true, MCP GPIO, that's the MCP, that's the MCP23017, and it's 2 to the power random. So it's going to give me a binary number that will only have a 1 in it, and everything else will be zeros. So 2 to the power 0 is 1, so that'll be 1 at the end. 2 to the power 3 will be 8, so it will be 100. So that's nice. That's how my little program works with the flashing the lights. But the interesting thing here is this thing here, and it's a library. And we're telling it that the library runs on the I2C bus at address 0x20, which 0x is hexadecimal. So let's have a quick look at the library, which is, where's my library? There it is there. There's my library, and it is, as you can see, it's written by Mike Causer. So thank you, Mike, for posting that. I can use that because it says you can use it, and everyone else can. Brilliant, well done, good man. That's probably a lot better programming than I could ever do. And there's lots of stuff in here. It's object oriented. It has classes in there, class for report, class for everything else. It's got the ampersand, which is a decorator thing, which there's a lot of quite complex Python in here. But at the end of the day, all I've got to do is, if I save this script here, file, save as, to the MicroPython device, and as mcplib, if that file is alongside my program that runs on the ESP, then you'll be able to import it, and that's what we've done. I won't save this now because I'm not sure it's quite the right one. If I look at the LED flash program here, it says import machine, that's from system, lib mcp23017. It's pulling that in from alongside itself on the ESP. So you need to save that file to the ESP. And then you can run it. We'll say, should we run the program? Let's run the program, see what happens. There's my little LED flashy things here. Let's just run it. So we run the program, and there we go. Whoa, little flashy lights, brilliant. And you can stop the program if you want as well. So there we go. You can change your ESP32. Let's just stop my little share. Yay, there we go. So you can change the ESP32 to MicroPython, and you can install Thonny on your little computer, your desktop computer, or your Mac or Macintosh, whatever it is you've got, and you can then talk to ESP, program it, and then whenever you get the ESP, I mean, this is running now as it is. Did I overwrite that? I overwrote the thing when it's on there, yeah. So whenever you power the thing up just from battery, and here's my little battery thing here, then it'll just run automatically if you've got that program in main.py. So there we go, that'll do for today. So we've got the LED flashy lights. The next thing to do, I'm not sure what's the next thing to do, is maybe to get this thing working here, which is the SD card, because I want to save to SD card. And in addition to that, I want to get the camera working as well. We have an OV, I think it's OV2640, which is just a standard 5 megapixel camera. And I think I'm going to try and take the infrared filter off that to make it a night cam as well. Righty ho, have fun. Thank you.